Hi, I'm Isaac, and today we'll be exploring the science behind pressure cooking beef brisket. Have you ever wondered how to turn this tough piece of brisket into this tender and juicy dish? Brisket is a cut of meat from the lower breast or pectoral muscles of a cow. Because this area is so well exercised, it makes for a quite tough piece of meat that is full of connective tissue. In these connective tissues, collagen is abundantly found here. Collagen is responsible for holding muscle fibers together, which is an important factor to consider in how tender or tough the meat will be when it's cooked. Traditionally, brisket is cooked low and slow over time to break down the collagen through hydrolysis. When the meat is exposed to heat over a long period of time, the triple helix strands break down into gelatin, a substance that will melt and lubricate the meat. So today we'll be using all of these 10 spices here. They're all acidic except for salt, which is neutral, and I know this because I've done the litmus paper tests. So now that we've finished mixing all of this up, we're going to start putting it on our beef brisket. Now that we have marinated our beef brisket, we can now refrigerate this overnight or for at least 2 hours to allow the flavor to penetrate into the meat. Now we're going to create an acidic base for our beef brisket to cook in the pressure cooker. We can now place our marinated meat inside to cook for 1.5 hours. Because we're using a pressure cooker, you may be wondering, how will the beef brisket be tender and juicy if it's not cooked low and slow? Well, to answer that question, we must first understand Boyle's law. Robert Boyle was a famous chemist from England, and in 1662, he was the one who discovered that if you pushed on a gas, the volume would decrease proportionally. This law states that the pressure and volume of a gas are inversely proportional when temperature and gas remain constant. In a pressure cooker, as the volume of the steam decreases due to confinement, the pressure will increase, increasing the boiling point of water and allowing the food to cook faster. So now we're going to do an experiment to demonstrate Boyle's law in action. So all we will need is a syringe and some mini marshmallows. The first step we're going to do is remove this plunger. We're going to insert a marshmallow into the tube. Now we are going to demonstrate what happens when the pressure decreases and the volume increases. Reinsert the plunger until it almost touches the marshmallow and place your finger over the tip. Now pull the plunger back. As you can see, the marshmallow has become bigger. And to demonstrate vice versa, finger on the tip, push down and it becomes shriveled and smaller. In real life, Boyle's law can be applied not just to marshmallows, but to scuba diving. When a scuba diver ascends too quickly, the nitrogen in their blood and tissues forms bubbles, which can block blood flow, causing injury or death. This is known as the bends or decompression sickness. Decompression chambers or hyperbaric chambers are used to treat this sickness by applying pressure on the human body. In conclusion, today we have learned about how Boyle's law can be applied to pressure cookers and how collagen hydrolysis is achieved by adding heat and acid to break down the collagen. Goodbye and thank you for watching. Cheers.